we have to understand that our kernel can be preemptive and non-preemptive. So we can see the different mechanisms in which you can basically do this critical section. Okay, how you can handle this critical section. First we have the lock. Okay, first, in order to understand lock, here you see that it's actually very easy, it's not that fancy. A lock is what? A synchronization mechanism which is used when concurrent programming, used in concurrent programming for us to ensure the mutual exclusion, meaning only one thread or process can access the shared resources at a time. So when multiple threads access the shared data simultaneously, we can get what? Race condition, leading to incorrect result. So if two threads do this at the same time, updates can be lost. I have already told that in order to get this critical section, what we have to basically do is that when two programs are coming and it's running, let's say concurrently it is running. Okay, so when two programs are running concurrently, so we have to ensure mutual exclusion here, meaning only one thread or one process can enter the critical section at a time. Only one process can enter. So when multiple threads is accessing the shared data simultaneously, what happens? We told, if multiple threads are accessing the same shared data at the same time, or if it's like both of them are concurrently running, then it results in what? Race condition. So what happened is that it can override the changes which is there. So we are going to do the lock. In critical section, the first mechanism that we are going to do is lock. Lock is actually preventing this by enforcing only one thread enters the critical section and others must wait. A spin lock is a lock where threads wait in a loop spin until the lock becomes available. Okay, so this is one of the most important things that I want to talk about here right now. So what is lock? I told you, a lock is what? This would prevent the race condition. How? It would allow only one thread in order to enter the critical section and make the others to wait. So that means this type of lock which makes the other process to wait and only one process can enter the critical section is called as a spin lock. That means in a spin outside our loop, they will wait. In a spin, right, in a loop, they will wait until the lock becomes available. So let's say this is our part where we are having the entry section, the critical section and the exit section. So until this section becomes free, in a loop, what happens is that in a loop outside, the process would spin, process would wait for its turn to enter into the critical section. So the property of the spin lock is that, as you can see, it's very kind of, I would say, it's simple, fast when critical section is short, and no context switching overhead. So here if you see, it is actually okay. Simple is an easy property for us to understand. Now what is the next property? Fast when critical section is short. This means, as you can see, if there are a lot of process waiting, spinning here, so if the critical section is small, only one or two shared data is there, it can easily go away, leave the critical section fastly. So when critical section is slow, more process can enter much more fastly here, which is waiting outside, because the critical section is short, so it becomes much more faster. So it is fast when the critical section is short and there is no context switch overhead. You are not going to when you're switching between different process, you are not going to happen in such a way that the switching is happening switching is happening a lot of time, very much difference is happening, then it can result in what? Overhead. So here there is no context switch overhead. Okay, now disadvantages is that it wastes the CPU while spinning. As I told you here, most of the process which is not entering the critical section is waiting outside and they are spinning. That is what I told you. So when it is waiting outside like that and it's spinning, it can waste CPU's time, so it can lead to poor performance. So it's not fair. There is no particular order and in which they can enter, right? The process would wait outside only until it gets a lock. So it's not fair, as well as it's it has to wait a lot of time, right? So CPU utilization is basically decreased. When CPU utilization, when it's wastes CPU, means what? It is a poor performance. That is one important thing that you have to understand. Okay, so spin lock's properties you have to understand. It is simple. Now context switching overhead is then it is much more faster when the context section is short. Disadvantage is that since the threads are spinning outside, this can waste the CPU cycle, so it can lead to poor performance, right? Because it wastes the CPU cycle, it can lead to poor performance, and you have to understand that it's not fair. So now hardware based solution is that you have two algorithm for achieving this spin locks. Okay, that is the first is the test and set algorithm, and the second is compare and swap algorithm. In this class we are going to learn this test and set algorithm. In the test and set algorithm, you have to understand that we are going to first, we have this shared lock. You have a shared variable, you have a lock. Okay, so you have a lock like this. This is a shared variable lock. First the lock would be false, because what? Lock false means what? Lock false means that the lock is free. That is what it means. Okay, that you want to understand. Lock is false means the lock is free. So first the lock would be free, right? So first they initialize this lock variable, this shared variable of lock, to be false. The shared variable lock would be initialized to false initially, because initial condition we know what the critical section is free, so we will initialize this lock to be false. Now test and lock algorithm works in this way. How test and lock algorithm works? So I'm not showing the code, maybe it will become like, I will show the code but not right now, maybe it will become confused to you. So first, what does this test and lock algorithm says? I'm going to write it in my own words. Okay, it always returns whatever value is sent to it and sets the lock to true. That means initially my lock is true, sorry, my lock is false, that means it is free. So what happens here is that, let's say initial condition I'm going to write, initially my lock is basically false. Okay, so what happened when this lock variable is going, so lock is this test and lock is taking what the value of the lock itself. So when this test and lock, if you see the lock to be false, what it will do is that it would return that same value. So that means it would return the same false, whatever value has come for the lock, that value it will return itself. Okay, that is what it is saying. It always returns whatever value is sent to it. Then after that it would create another, let's say RV named another variable before this returning false, that would set that lock's value to be, let's say, true. Okay, and after that whatever lock's value come, that would be returned. If first the lock's value is false, that false value would be returned. Okay, and it would set, before returning that false value, it would set the false lock's value to be true and return whatever value come here, that is the old value of the lock. That means, so the first process will enter the critical section at once test and lock will return false, and it will break out of the while loop. The other process cannot enter now. So now what happens is that, look, this is one important thing that you have to understand. So here what happens is that you have a do condition, do while true condition, and inside this you can see another while loop. Okay, this while loop which is going to this function, that is test and set of and of lock. So initially, let's say, okay, understand this, P1 is coming, P2 is coming, P3, these are the different processes coming. Initially my lock is what I told you, my lock is false. So that means when my lock's value is false, means it would break from this while loop, right? It would break from this while loop and enter the critical section. If my lock's value, because this value becomes false, means what? It can break from this while loop. So that means, I told you, if the lock's value is false, means the lock is free. So it breaks from the while loop and enter the critical section. Okay, enter the critical section. So now it is enter the critical section now. Now what happens is that, now you have to see the test and set code. This is a test and set code. Here if you see the test and set, first here it would, this lock would come here. This is a lock variable, that what is there in the lock. Okay, first in the new variable, let's say RV, I will write whatever is a value that is coming here. If the lock's value here is true, then I will write it in the RV true. If it is false, then I will write in the RV false, and I will set the lock's value to be true then. Then I will return this old value of RV, that is whatever I came here, that I will return, but I will set the lock to be true. Understood? So here what happens is that, now what happens is that when initially my value of lock is false, that means this condition, that this target becomes false. Target is my lock's value, that becomes false. So RV would contains what? RV would now contain false, and it will put the lock's value to be, that is target is true. It would set the target value to be true. Now the lock's value would become what? True. And I will return what? The RV. RV contains what? The false. I'm going to return this false here. So when I return the false here, that means a while loop is breaked, and now I enter the critical section. Now what happens? Let us see. I told you P1 came. Now P1 is inside the critical section. Now P2 comes. So we know in the other case here we have set the lock's value to be true. Now the lock's value is true. So now what happens when I test and set this lock condition? If I go, now what happened? My lock's value is true. When my lock's value is true, my RV's value is true, and my lock, again I am setting the lock's value again to be true, and I am returning true. If I am returning true, means in this while loop what I am having is true. So it will be spinning in the while loop. The P2 would wait in the while loop. If it is false only, it can break from the while loop, but it is true. Now let's say P1 exits from this while loop. Now the lock becomes false because P1 exits from the while loop. Now what happened? My lock's value becomes false because now the lock is free. Because now the critical section is free, because I have put the lock's value false after P1 exits. Now again P2 is spinning in this while loop. It will again check the test and set. Now the lock's value is what? Now if you see, now the lock's value is here is what? It is basically false. Now P1 leaves, so it becomes false. So RV becomes false. We are returning RV, means we are returning false, and we will set the lock's value again to true. So that means now what happens, guys? Now what happens here? This becomes false. Okay, this becomes false means P2 can now enter the critical section. Okay. So, and since P2 enters the critical section, here it says the star target equal to true, means it sets the lock's value to be true. Now the lock value becomes what? True. So now the lock's value is true. So when P3 tries to enter the critical section, and if it do the test and lock, the lock's value is true, it would return true. So that means it will still be there in the while loop. Now when P2 exits, it would set the locked value to be false. When the lock value is false, when P3 is spinning in this while loop, it will see that when the lock's value is false, it would return the false value. So if it returns the false value, it will exit from this while loop, and now P3 can enter the critical section. Understood? This is how the test and set would basically work. Understood? Now this is atomic. Now modern machines provide special atomic hardware instructions here. That is, atomic means it's not interpretable. That is, when one first thread enters critical section, other threads keep spinning in the loop. The three axes of evaluating spin lock is correctness, fairness, and performance. So here, non-interruptible means when one is entered, then it is not interpreted another one. The other process is spinning here in the while loop. Understood? That is why we say it's non-atomic. Sorry, it's atomic. Atomic means what? So this machine, that is, which is working in this test and set algorithm, the machine which is working in this test and set algorithm would be what? Would be atomic. That is one important thing. Why we are saying atomic? Because it is non-interruptible. That is why we are saying it is atomic. So those which is working in the test and set is basically what? Atomic. So if you have any doubt, if you still didn't understand this atomic, please tell it in the comment section. It's not atomic, the test and set. Okay, because in the next class we are going to learn compare and swap. Thank you.